Okay, let's go and figure this math problem out. And you can see here we want to add up these various terms, and these terms right here have the variables a, b, and c. So anytime you're doing a math problem and you have some variables involved, that pretty much puts it in the realm of algebra. So let's figure this algebra problem out. That's a pretty vague description of what's going on. So let's just take a closer look at this problem. We have 1 plus 1 over a plus 1 over b plus 1 over c. So here we have fractions, right? You would kind of describe these as fractions. There's a numerator, there's a denominator. But technically, we don't describe things that look like fractions or are fractions that have variables as fractions. That's not the correct terms. This is a fraction, 2/3, but 1 over c. Technically, you would not describe that as a fraction. It's described as something else in algebra. Matter of fact, if you know the answer or what kind of category or topic we're talking about in algebra, put that into the comment section. Better yet, go ahead and put your answer if you know how to figure this out in the comment section. I'm actually going to show you the solution to this in just 1 second, and I'm going to do this problem two different ways, okay? Now, if you're taking any sort of math course that involves algebra, this is something you're absolutely going to need to understand. So anyways, I'm going to get to all of this in just 1 second, but first let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I've been teaching math for decades, and I'm telling you right now, all students can be successful in mathematics, but they really need two things. One, they need a lot of encouragement. Well, actually, let's say three things. One, they have to have the desire to learn math, okay? But that kind of comes from someone who's encouraging them, telling them they can do this, okay? And I'm telling you right now, you can learn mathematics, but most importantly, what you need is great math instruction, clear, understandable, and comprehensive. So if you need help in your current math course, or maybe you're preparing for some sort of special test, something like the GED, SAT, ACT, maybe a teacher certification exam, ASVAB, anything with a math section on it, or if you're homeschooling mathematics, check out my math help program. I'm going to leave a link to it in the description of this video. I literally have over 100 plus different math courses covering all these categories and much, much more. I'm also going to leave links to my math notes in the description of this video. Now, hopefully, you're taking your own awesome math notes. If you are not, you need to really work on this. It's so, so important for your ability to learn math, comprehend math, and retain mathematics, right? So become a better note taker, and all sorts of magical things will happen. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's get into this algebra problem. And the topic that we're talking about here is called rational expressions. Okay, rational. Let's kind of write that down. Rational expression. So if you are learning algebra, okay, if you look in your textbook or whatever syllabus you're dealing with, look for this rational expressions or rational equations expressions chapter or unit. Okay, now the word rational in mathematics, okay, especially in algebra, refers to numbers that can be expressed as a fraction of integers. That's kind of just a roundabout way we can kind of say it. So this here, 2/3, is a rational number because it is a fraction where both the numerator and denominator are effectively an integer, okay? Zero point 0.5, all right, is also a rational number. It's a decimal because this number can be expressed as a fraction of 5/10. But these here in arithmetic, we would say, oh, this is the fraction 2/3, this is the fraction of 5/10. Now, when we're dealing with fractions where the numerator and denominators contain variables, then we're going to write something like this, 2x over x plus 1. This right here, we don't say this is a fraction, okay? Sometimes some textbooks might refer to it, but technically that would be incorrect. This is a rational expression, all right? Now, we're talking about things that have a numerator and denominator, but the numerator and denominator are what we would say polynomials, okay? So I don't want to get overly technical, but anytime you are dealing with fractions where there is a variable contained in the numerator and denominator, you probably it's a good bet that you're dealing with a rational expression. Now, this would be an irrational expression, or we would be adding an irrational expression right here. Okay, this right here is find the sum or add up these rational expressions. If I make this into an equation, now you're dealing with a rational equation. All right, so it's important that you know the names to various topics in mathematics, because you're like, oh yeah, I'm really struggling with this. I don't know how to describe it. This thingamajiggy, this, you're talking like, yeah, it's important that you know the names. Now, most students, a lot of people don't know the names. That's why I walk through this to make sure you understand the big picture topic. Okay, so here is the answer. 1 plus 1 over A plus 1 over B plus 1 over C is equal to ABC plus BC plus AC plus AB all over ABC. Now, if you have these terms in different orders, but as long as you have this numerator and this as your denominator, you did get the problem correct. So if you got this right, pretty impressive stuff. Matter of fact, impressive enough to earn yourself a nice little happy face, an A++, a 100%, and a few stars, so you can have an extra special day. Nice job, okay? All right, so let's go ahead and talk about how to do this problem. Now, the first thing I'm going to say is, yes, these are rational expressions, but we need to think of what we learned about fractions way back in elementary school, okay? That's why it's so important that you master basic math, arithmetic, okay, before you move on to algebra. There are a lot of students, they think, oh yeah, once I learn this basic math, I could throw that away because now I have my calculator and now I could just do algebra and I can forget that stuff. That is absolutely wrong thinking, okay? You need to understand all those things you learn in basic mathematics, especially fractions and all that kind of good stuff, because it's going to be applied in a problem like this. So let's get into this right now. All right, so 1 plus 1 over A plus 1 over B plus 1 over C, what is this equal to? Well, first thing is this, okay? Hopefully you have a pretty good understanding of fractions. Let's just go ahead and make up another fraction problem with numbers. So let's say you have 1. Let's express this as 1 over 1. So we can see that explicitly as a fraction. Let's say we had 1 over 3. We're going to add that to 1/3. Now, A and B, these are different numbers, so we'll have 1/4 plus 1/4 plus, let's say, 1/5, okay? So you can see we have different denominators here. So 1, 3, 4, and 5. So how would I do this problem right here, okay? Well, hopefully you recognize that, well, listen, I can't add up these fractions because all these denominators are different. So I'm going to have to find the LCD, and you would be absolutely correct. Okay, that's what we're going to have to do here. Now, if you're looking at this problem, I'm assuming, and I hate to assume that you know fractions. If you do not really kind of feel strong about fractions right now, I'm going to give you some recommendations. Matter of fact, let me just tell you real quick. I have a ton of videos on my YouTube channel about fractions, but I would also suggest 2 courses. Primarily my pre-algebra course. I cover fractions and algebra as well. So check that out. That's probably my best recommendation. But let's just look here. We can only add or subtract fractions when the denominators are the same. So if I have 1/7 plus 2/7, because of the denominators are the same, okay, there's no need to find a lowest common denominator. We have the lowest common denominator right here, 7 and 7. All I have to do is simply add the numerators, 1 plus 2 over 7. So this is 3/7, okay, because I have the same denominator. Here, I do not have the same denominator. I'm stuck. So the way we approach this is the way we know, or the way we learn how to add fractions with just numbers, okay? Even though this is called rational expressions, the same concepts apply in terms of basic arithmetic, in terms of fractions, all right? So hopefully you kind of see that. And one of the best things you can do when you're stuck on an algebra problem is just to replace the variables like this with a number and think about how you would do this in arithmetic and then try to kind of apply that back to your algebra problem. But anyways, hopefully you see here that we do not have a common denominator, so we're going to need to find the LCD. So my next question to you is, how do you find the LCD? And most students, if I said, okay, 1/3 plus 1/5, they'd be like, oh yeah, the LCD is 15, Mr. YouTube Math Man. That's so easy. Well, that's wonderful. And if I asked you, like, well, how did you get that answer? You would probably like, well, I just knew it. Well, what if I made the denominators like 506 and 38? Okay, what would be the LCD? Now, this would be much more challenging. A lot of you would be like kind of, mad about that. Like, hey, I don't want to do that problem. Just give me the easy stuff. Well, it doesn't work that way, right? We need to know exactly how to find the LCD. All right, so the LCD, the lowest common denominator, is effectively the product of all the prime factors of the respective denominators involved. So what do we have here? We have 1. So this denominator here is 1. Okay, anytime you want to see a number as a fraction, like the number 6, just put it over 1, and now you can see its little denominator. So here's 1, here's A, here's B, and here's C. All right, so what are the prime factors? Well, prime factor of 1 is just simply 1. Okay, so let's go ahead and start building the LCD right now. What's the prime factor of A? Well, it's just 1 times A, so we need an A. Okay, so we need all these prime factors represented in this product. Okay, so we need 1, we need an A, we're going to need a B. Okay, you can see here I'm building this out right here, and we're going to need a C. So the LCD is going to be 1 times ABC, which will be ABC. All right, so that is the LCD, and hopefully you understand how to find LCD as easy as your ABCs. All right, so let's move forward and apply that LCD now. Okay, so here we have 1 plus 1 over A plus 1 over B plus 1 over C. What does this mean? We just found the LCD. Well, that means that we're going to have to rewrite each of these terms, okay, rational expressions, each of these fractions, such that the denominator has A, B, C in it. Okay, now we're going to have to figure out what is going to be in the numerator, right? So effectively, we have to rewrite each one of these rational expressions, fractions, I'll kind of loosely refer to them as fractions, such that the denominator has A, B, C, and then each of these rational expressions or fractions will have the exact same denominator, then we can add these things up. So let's go ahead and do that now. Okay, so how do we do this? Well, let's carefully review the process here. So we know each of these fractions, okay, we'll just call them fractions for now, has to have the denominator A, B, C. So let's take a look at our first number. We had 1 or 1 over 1. So how do I get an ABC as a denominator when our fraction here is 1? Well, easy. Let's just multiply it by ABC. ABC times 1 is going to be ABC. Well, here's the deal. If I multiply the denominator by ABC, I also have to multiply the numerator by ABC. So this fraction, 1 over 1, is going to be ABC over ABC, and anything divided by itself is 1. So all we're doing is rewriting this fraction a different way, but the fractions are equivalent, okay? All right, so our next one was 1 over A, okay? Now I have to get this denominator, I have to go from A to ABC. Well, if we look at ABC, and this denominator already has A, what I'm missing is BC, okay? So if I multiply this A by a BC, I will get an ABC. Now, remember, when it comes to multiplication, order doesn't make a difference. ABC is equal to CBA, which is equal to BCA, etc., etc. So it doesn't make a difference. So BC times A will get us ABC. So if I multiply the denominator by BC, got to multiply the numerator by BC, and there you go. All right, so we can make these adjustments for these two using the same kind of concept, right? So I have a B here, so to get an ABC, I got to multiply by AC, right? So I get AC over ABC, and then I have a C right here, I need an AB, so AB being multiplied by the numerator as well, so we get AB over ABC. So you can kind of just pause the video, see the work, but this is the adjustment, right? We're rewriting each rational expression, each term, each fraction such that we have new equivalent fractions, but we have ABC as our denominator. So now we have the same denominator. To get the answer here, all I need to do is add the respective terms of the numerators. So let's go ahead and do that now. And when we do that, we're going to get ABC plus BC plus AC plus AB all over ABC, and we'll write it just like this. Now, order doesn't really make a difference. And when we look at these terms in the numerator, what we want to do is just quickly see if we can simplify this. Do we have any like terms? Well, AB and AC we can't add together. AC, AB, BC, no, these are all different terms. So we just leave this as one big numerator like this. Technically, you can have BC plus AC plus AB, and then have the ABC over here. It doesn't make a difference. Order doesn't make a difference, but the in terms of ABC being in the denominator, yes, this is our answer. So hopefully you understand this process, but now I'm going to show you a different approach, okay? And both approaches are perfectly fine. Now, before I show you this approach, let me just kind of erase, oh, no, I don't want to do that. Let me just show you this right here. So what I'm going to do is I'm going to kind of group together this problem. Here's our original problem, 1 plus 1 over A plus 1 over B plus 1 over C. I'm going to kind of group these together this way. I'm going to figure out what the sum of these two rational expressions are, or two fractions, and I'm going to add these two up, and then when I get the answer, I'm going to add up those two fractions. But let's quickly look at something here. Let me just move this down. Let's review what I call the bow tie method. It is one of the most awesome things you can learn in mathematics. So when it comes to fractions, it's a must-know, not only for arithmetic, but for algebra as well. So here we have 2/3 plus 1/2. Right now here we clearly do not have the same denominators. We do not have the same denominators. So we can go through the whole process to find the LCD and do what we just did previously, okay? Now that's not necessary because we can use this beautiful little kind of hack. I call it the bow tie method because it has this pattern like a bow tie. So here's how it works. We're going to start from the bottom right and we're going to go this way, okay? Always from the bottom right in this particular pattern. So this is going to be 2 times 2, that is 4, okay? Now this is an addition problem, so I'm going to put addition, and then I'm going to go from the bottom left, and I'm going to go across this, I'm going to go in a diagonal manner this way. Now I'm going to multiply. 3 times 1 is 3, okay? So again, you have to do this exact specific pattern over, okay? 3 times 2 is 6. Okay, so what we're doing here, the first two parts of this problem, we're building out the numerator. 2 times 2 is 4, plus 3 times 1 is 3, over 3 times 2 is 6. So this is our numerator, so this would be 7 over 6. That is correct answer. Now, if I was to find the LCD would be 6. I would multiply this by 2, that by 2. You can see I would have a 4, then this by 3, and this by 3. I would see, but I have a 3 here, a 4 there, same thing. So this works, okay? But the great news is not only does it work with numbers, it works with variables as well. So if you understand how to work with just numeric fractions and you understand all these little techniques, then you're going to save yourself a lot of heartache in algebra. So let me show you how we can apply this without, or how we can do this problem without even thinking about the LCD. So first thing I'm going to do, again, I'm going to group these together. I'm going to be like, all right, let's just kind of start adding up some fractions, and we're going to use that bow tie technique. All right, so here we go. So I'm going to look at this 1 plus 1 over a, the same thing as 1 over 1, plus 1 over a. So I'm going to go a times 1, right? I'm just following that same pattern I just showed you there. A times 1 is a, plus 1 times 1 is 1. That's my numerator. All over 1 times a is a. I am done. I just added these two up. Super easy. Let's go ahead and add up these two rational expressions or fractions. It's going to be c times 1 is c, plus b times 1, which is b, over b times c, which is bc. So now we have two fractions, okay? This fraction and this fraction. Let's add these two fractions to get the final answer. Now, one thing I want to caution you, in algebra, let's kind of erase this here for a second. Anytime you have a sum or difference, some sort of expression like this, CB or A, C plus B or A plus 1, it's always a good thing to put grouping symbols around these expressions. Oftentimes it's not required and you won't necessarily feel like that you need them, but I'm going to tell you right now, put those in because that will save you some heartache making mistakes, common mistakes when you want to manipulate these two rational expressions, right? Just getting a good habit of putting grouping symbols around sums and differences with various expressions in algebra, okay? Anytime you have things that you're adding up or subtracting, just put parentheses around those. So you're going to see why this becomes very important, because we're going to go ahead and add these two fractions right now using the bow tie technique. Okay, all right, so let's go ahead and do this right now. So remember, I start from the bottom right and I multiply this way. So this will be BC times A plus 1. Okay, now if I didn't have these parentheses here, a lot of students can get this wrong. They might go BC times A, but they'll forget the plus 1. So in other words, this answer, BC times A plus 1, is going to look like this. BC times A plus 1 plus A times C plus B. A times C plus B all over A times BC, which is ABC. Okay, so let's go ahead and simplify this now. So I'm going to use the distributive property. Actually, let's go ahead and take it from here. See, I kind of pre-write these templates and try to be nice and neat about it so we can focus in on what we need to do. So let's go ahead and distribute the BC to the A. Okay, so BC times A is what? Well, it would be, it's B times C times A, or ABC. Okay, then we have BC times 1, which of course is BC, plus A times C is AC, and then A times B is AB, all over ABC. And if you notice here, this is the exact same answer as what we got way back over here. Okay, same thing. So two different approaches, and you basically need to know both ways. Okay, you can't be saying, "Oh, I just love to use the LCD. I don't need to know this little bow tie hack." Believe me when I tell you, you want to know this. Okay, this is extremely helpful in algebra, but you do need to understand the lowest common denominator, how to find it. But in order to find the LCD or to understand how to work with fractions, you need to understand arithmetic. Okay, so here's the deal. You need to ask yourself what you know and don't know. Okay, if you're like, oh boy, I'm really confused. I don't understand quite how to find the LCD, well, then, hey, make yourself a nice little to-do list, all right? One of the great things about mathematics is the following. If you know what you don't understand, that's actually good news, because now you know what to work on, okay? The worst thing that can happen is like, I don't even know what I know or don't know. Well, that's, not a situation that you want to be in. But if you need help with this, additional help, again, I'm going to kind of direct you towards maybe like my pre-algebra course, Algebra 1 course. If you're looking to relearn basic mathematics, then you might want to check out my Math Foundations mini course. But what we're doing here, working with rational expressions, this would be probably more appropriate for those of you that are like in a first year Algebra 1 course. Maybe some of you are in Algebra 2, I got that course as well. Or maybe some of you are superstars, you're in pre-calculus. Whatever the case is, go to my Math Help program and check out those various courses. But with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.